A local park is planning a ticketed summer concert event featuring local bands. They've determined that the demand for tickets can be modeled by this. What is this function right here? What does this represent? Like in real world terms. Okay, quantity. What does quantity mean? So how many people are going, right? Or how many tickets are sold, right? Okay. Now, where X is the price per ticket in dollars and Q is the number of tickets sold. The fixed costs for hosting the concert are $60,000 and the variable cost per attendee is $25. Okay, so how many people would attend the concert if it were free? Now, y'all were jokingly saying like anybody, well, duh, but like based off of this, let's say that the price was zero. So let's plug in zero into this equation. 6,000 times 50 times zero. So what would you get? Okay, so if the concert was free, it would be 6,000 people. What is the maximum ticket price before no one would attend the concert? So what is that asking us to do? Okay, so that would mean that nobody would go. So that would be zero equals the equation. And now we're solving for X. So how are we going to solve for X here? Okay. So subtract 6,000. And then what? Okay. So 6,000 divided by 50 gives me what? 6,000 divided by 50 gives me what? Okay, so 120 would be the maximum price before nobody would go. Yep. Okay. Ready for the next one? Are we okay on those two? Okay. All right, on the next one, we got R times X. So X is just the price, right? And Q, what was the formula for Q? 1,000. Okay. Now you can leave this like this on the quiz. On your multiple choice question on the test, you're going to have to distribute and simplify. Yeah? Okay. At what two prices is the revenue zero? So I would go into Desmos and I would type this equation in. Okay, so it crosses at zero. 120. 0 and 120. The revenue is zero at 0 and 120. Okay. Everybody okay? What price would have been the maximum revenue? So what are we going to look for on that? The vertex, so the highest point, right? Good Lord. So how much did they make? 180,000 for the maximum revenue. So everybody see where I'm getting that? All right, so how many tickets would be sold at that price? So what is the X value? It would be 60. What would the revenue be at that price? We already asked that. We already asked that. What's up, friend? Oh, Mia, come here. At the end of class? Okay, cool. Thanks, friend. We already asked that right here. So the max revenue. Yeah. That's at the end of class. Yep. Okay. Now, for the cost, we learned about this equation last week. Okay. Remember, A is your fixed and B is your variable cost. Okay. Majority of your quiz is write the equation given this information. So, where does it say fixed costs? And then what is the variable cost? 25. 25. So, we're going to write that. So, C of Q is going to be 60,000, which is our fixed, plus 25 times Q. Remember, if Q is right here, Q has to be in your equation. For the next one, it has X. We're going to write the exact same equation, but instead of writing Q, we're going to write the equation for Q. So 60,000 plus 25 times what was the equation for Q? And you notice how there's an X right here? There's an X in that parabola, or I'm sorry, in the parentheses. Okay. Can you write the equation? They tell you the fixed and the variable cost every time. Okay. At what two prices will the cost equal the revenue? Okay. So what we're going to do is we already wrote our revenue equation onto Desmos. That's this guy. Now we've got to take our C of X and write it out. So that's going to be 60,000 plus 25 times 6,000 minus 50X. Now, what we want to do is see where they overlap. Why are they not overlapping? Hold on. Yeah, I gotta reset. Go home. There we go. There we go. Huh? Oh my God. Wasn't me. Now, what you could do is you could set these equations equal to each other and solve.
Okay, but how is it? Because did you say we can like do the thing where it's like you put it in a table?
You can.
How we do it?
You could also do this. Hold on.
They're not gonna do it.
Scrolling.
Because we got all out of my time.
Let's say we set it equal to each other. Let's see if it'll show us. Minus 50x. Okay, so get rid of these two. Go back home.
Oh,
It's 40.
but it's understanding too.
Well, let me zoom out. Boom.
Oh,
Okay, so when you do this one, so with your costs and your revenue, if you type them in and set them equal to each other, it tells you where it crosses the x-axis. Good on that one? Okay, so they want to know when the cost equals the revenue, right? So what we did was we wrote out the cost and we wrote out the revenue formula and set them equal to each other and then checked where it crosses the x-axis. Does that make sense? Good.
Thank you for that solution.
You're welcome. So are you good? Okay. All right, so that's gonna be at 40 and what else?
105.
Okay, so that's where the tickets are, right? Because that tells us the X value. Now the price is you right. Okay, my bad. All right, so 40 and 120. I need a nap. I'm going home. Okay. Now, here's the problem. I don't know, man. That one's bad. Okay. So this is the price. Okay, now how do we figure out how many tickets are going to be sold? No. What's your formula for Q?
60,000. Or excuse me, 6,000 minus 50.
Okay, so for 40, you're going to plug that in here. And that's going to tell me how many tickets. Go. Put that in. Haha, gotta do it. 4,000? Okay, then you're going to take 105 and plug it into that equation.
Say 4,000?
No, 105.
Oh.
Plug it into the equation. No. 750? Okay, less. Now we've got to figure out how much they're going to be sold at. Like, how much money are you going to make off of that? So you're going to take the C of X formula and you're going to plug in those.
That's the cost.
I'm sorry, that you're going to plug in those into that. So watch. You go in here. So much math. You've got your equation, right? You're going to go into the table and then you're just going to type 40 and then you're going to type 105. There are your two numbers. Agreed. No. No.
Yeah, let's go park it, please. It'll strengthen
Your what?
our class chemistry.
No.
All right.
Who? If you can name every single person in this classroom, we'll do open note. You can't ask their name though. So revenue, when is it greater than cost? Something you can do on here. I'm thinking that I actually will let you do it. What was the R of X formula?
6 or X parentheses 6,000 minus 50X.
Revenue?
R of X, right?
R of X. So X times 6,000. Okay. We're trying to figure out when that is bigger than the cost. What was the formula for cost? C of X.
50,000 and 25 times 6,000 minus 50X.
So when is revenue bigger than the cost in between 40 to 105? Write it down. Yes. Notice how I did the inequality? I didn't have to do any work.
So how would I write that? Let's put it.
From 40 to 105. It's an inequality.